What is going on here in the terminal? I'm running this. It's going to query the sensors. AMD GPU. This is a Threadripper system that has an R9700 in it. Maybe I'm interested in the CPU frequency. Min-max average unit current there. It's like 1221. I just started it. There's not anything running in the background. My power core there, disk statistics, HSMP. We did a separate video on HSMP. HSMP is enabled all up and down the AMD stack now, Threadripper as well as EPYC. And this is excellent geometry or insight into like the geometry of what's going on your CPU. So socket power, Z clock, fabric clock, it's like what's going on the CPU? Where's our power budget going? Maybe I can steal some power budget from the PCIe and send it to the cores. HWMON is built into Linux, of course, so everybody's probably familiar with that. And we have some AMD GPU insights from HWMON. That's different than the direct AMD GPU insights, which I'll talk about in a second. We got some insights from our network card. This is the Asus EC, which this is the Sage A. So this is the new version that otherwise doesn't really work correctly on Linux, which is annoying, at least for the sensors, the sensor package. ENP 1720, and chat if I'm wrong, or correct me, also comment, that sort of thing. But also the NCT 6799, which is a pain. It's like, oh, I'll just apt install LM sensors, or in this case, this is CashieOS. I will, yum. I'll Pacman-SYYU install LM sensors, or maybe I'll get LM sensors from -get from the AUR. You're still not going to get the NCT 6799. At least that's what I ran into. This is the straw that broke the camel's back. It's like, I just want good sensors in Linux for Threadripper. Where's my stuff? And so this is good. Notice there's not a voltage conversion table for this one yet. Don't worry about it. We're working on that. VBAT is fine, and the labels here are fine. We'll talk more about that. But like, look, this is full telemetry. Oh, maybe we want a graph. What is happening with that? Voltage, speed, RPM, power, temperature. It does more. So if you want to do PCIe and you want a breakdown of what all is in this system, now this is actually Greg Crow-Hartman's system that I'm still working on. And so you can see it's got the data center Optane, PCIe 4 Gen 4, the Action, the 10 gigabit Atlantic Ethernet controller, the wireless adapter, the Navi 10 XL, because that's the R9700, remember, 32 gigabytes. And so there is a lot happening here. This is sinfo. This is going to be open source, and this is made possible with support from you guys. But I also need more support from you guys, because this kind of stuff costs money. So we've also set up a sponsorship GitHub page. But let's talk about, let me transition here and talk about some of the other stuff that I've got going on. So hang on just one second. Okay, so that's sinfo, and that is one of the things that we're going to talk about. But this is also a weekly thing that I want to do on the Linux channel. I want to do a weekly show. It's not necessarily live, but there's a link for this show, for the forum thread, that has the full agenda, so you can get an idea of the other stuff that we're going to talk about. I think that we can discuss, like in the forum, like the community, like what sort of questions do you have, and just do a quick link roundup thing with just Linux related stuff. So we can talk about Linux related stuff. You can ask questions, because week to week, sometimes it's like, oh, this is an interesting thing that happened. And sometimes it's crazy stuff like, Red Hat closes a project, or Red Hat does something that Red Hat does. And, it do be like that sometimes. But most of the time, I'm actually just interested in being productive, and like, how do I use the tools to be more productive? And I don't really want to get bogged down in all the insanity. I feel like a lot of the Linux content out there is getting bogged down in the crazy. So I want to kind of do this weekly. I'm going to be at GTC next week. So if we do one of these from GTC next week, it should be with y'all, and we should say hi, because next week and that kind of thing. And so it might be another, I don't know if it would be an impromptu live stream, but We'll see. So if you're going to GTC or you're going to attend GTC virtually, I have a link for that in the forum, in the thread. So go to that, use my link to register. That is beneficial for me because NVIDIA is paying for my way into GTC, or NVIDIA gave me a free ticket into GTC, but I'm also giving away the Spark. So if you'd like a Spark, you check out the forum thread, because it's the one we've been using for stuff, and I've got one that I can give away. So you can win a Spark and do all that sort of stuff. But the Linux Weekly thing is meant to be, Linux Weekly news, hardware drivers, new developments, new fun, exciting stuff, new projects, and things before maybe it becomes a polished standalone video. Like sinfo, I would, obviously is going to get its own video, but y'all are the early adopters, y'all are the supporters, y'all are the evangelists, so thank you for watching and sharing and doing all this kind of stuff. But and we're going to do, like, even though this is a live stream, we'll do the Q&A at the end, because I want to try to run through my agenda really quick over the next 10-15 minutes, and then we will hang out together and I can play with sinfo and we can talk and chat, and I can catch up with all the stuff that's going on in the comments and that sort of stuff. So yeah, that's a lot of fun. Again, thank you to all of our supporters and everything for getting this started. I've already sunk a fair bit of development into it. Some more support, like sponsored projects on GitHub. I don't know. We're gonna figure out how to do this, because we now have tooling that allows us to work efficiently on these kinds of things. And I also want to like Patrick Uos on the forum has been helping me behind the scenes with a lot of this stuff for months and months. And a couple of things have fallen, well, 3 things that we're going to talk about in this stream have fallen out of that, which are really incredible, and I think sort of changes the game a little bit for this kind of stuff and for that. I've also been working a lot on SRIOV. You might have noticed some of the SRIOV threads on the forum. That would also be pretty good for a weekly format. So just as like a for instance, for example, Intel dropped their B60 cards, and I'm working on a full video for the B60 for SRIOV. And so B60 is the bigger 24 gig card from Intel, and you can run 7 virtual functions. There's already a thread for that on the forum, and so if you hadn't seen that, maybe this shows a useful vehicle for calling that out and saying, hey, if you're into SRIOV, like, things are getting a little more stable, because it was a little squirrely on the B50, and right now the most up-to-date official driver on the B50 is only 2 virtual functions, which is annoying and silly. It should be at least 4, but you got 7 on the on the other one. So, Linux Weekly, topic 1. Topic 2, and we'll talk more about that at the end. Topic 2, sinfo. So I showed you the sinfo thing. And it's a single static binary. It's written in Rust. Let me actually pull up the GitHub page that you can't see yet. All right, so let me transition. There you go. All right, so sinfo. Linux hardware information, real-time sensor monitoring, CPU, motherboard, GPU, USB, battery, PCIe, yes, hardware mon interface, collapsible groups, lots of cool stuff. You can also do configurable threshold alerts. So if you're worried about, like temp1, you can also change the labels. What I was talking about with like the labeling thing. If you haven't seen Rastaman, there's this thing with Rastaman that allows them to do labels. And so like that's what this is. And so like here's the Rastaman dim labels database file for like a Dell. And so you might be wondering, like, okay, LM sensor, this is it's a static binary. The dependencies are these. This is it, pretty much. If you've got HSMP, like you could have HSMP, you might not have the HSMP kernel module, and so if you don't, then it's not going to get telemetry for that. Just like if you don't have a hardware mod compiled into your kernel, you're not going to get info from that. But for the Nuvoton controllers and that sort of stuff, it connects directly. So there is a little bit of a warning here that it's going to do stuff on the I2 bus. It's going to do stuff trying to find like LM sensors does, and there is a tiny little bit of danger there. And so be careful with that. We're going to add a disclaimer to the README before it goes live. This is not live yet, but it should be live shortly. And but it's Rust. It's also Rust. I know some of you feel strongly about that. I'm just gonna have to ask you to like, don't worry about it. It is the right choice for this particular project, I believe. And you got some options for building, like if you know you're not gonna need like NVIDIA GPU input or output. On these monster systems like Threadripper, it does take just, you know, like any other sensor package program, it does take a little bit to bring it up. And it is kind of a pain to do testing across a whole bunch of different hardware with a whole bunch of different chips. So that's the whole reason like LM sensors has been a pain on Threadripper, is because like a lot of the time they'll use the same Nuvoton chipset, or like Asus uses a slightly different variant of Nuvoton, but the labels, like Asus will run VBAT into like VN1, and ASRock will run the VBAT, like a CMOS battery, into like VN7. And so Rastamen has kind of the same problem for DIMM labels on motherboards. It's like, which one do you use? Rastamen, everybody should be running Rastamen at this point, because it will workstation or anything else. And so like, these are the labels for like a Dell motherboard, and like here are the labels for a Gigabyte motherboard, and here are the labels for an Intel motherboard and a Lenovo motherboard. And so like, this is good. This is good project hygiene. This is good project organization. We are going to do it the same way, because obviously it is too much effort to maintain. Like, look, this has got to be low effort to add boards and sensors and documentation, and like getting Nuvoton to just tell you things is like pulling teeth. So we want it to be as low effort as possible and as forward compatible as possible, but also like supporting pull requests. Like, I don't want to like be digging through source files and complication to, it's like, okay, is somebody trying to do something bad with the project? It's like, okay, this is literally just, you know, a raw text file that is like, this is the labels for this. This is what it says on the silk screen. This is what it says on the thing, so that when you get a DIMM error, you know where the DIMM is. And this is built into Rastamen. So with that philosophy in mind, we do the same thing with the sensors now. This is how it's gonna be. You can also produce HTML reports and that sort of thing. So that's fun. Love the board-specific labeling ideas, especially like the Asus, if you're not familiar, they have the Sage, and now they have the Sage A. And the Sage A is like the newer version with a lot of tweaks and lessons learned in it. And it's, you know, it's like, how is this going to be different? PCIe speeds and labeling. We got some ideas in mind for adding some of that, and also doing some stuff for logging in alerts. And it's not that LM Sensors is bad or anything like that. It's just that I've in the past, you know, like some of you have probably been around for years and years and years. Like 2 years ago, we were like, there was a patch set for LM Sensors that added Nuvoton stuff for one of the ASRock boards. And the person helping me with that was not really super enthused at the amount of tech support that they received. And so this is kind of a more enchilada hug approach to that problem, maybe with a little more forward momentum and a little bit more forward-thinking tool in mind. And perhaps that will generate something that is more maintainable and nice for this kind of thing. So yeah, we'll take more look. We'll take more of a look at that in a second. Now, when you're working on a project like this, and you need to connect to a bunch of machines to test it and probe the I-square bus and do all this kind of stuff, that is also annoying. And like faffing around with all of it's like, did I get HSMP? Do I need to go compile HSMP? Is this kernel the right kernel? What do I have here? In our world of AI, I know, just bear with me for a second. Our world of AI, especially even local AI, wouldn't it be nice if you had a tool that you could just have the general procedure, and the tool could follow the general procedure? And it's like, you're going to have to do this, you're going to need a kernel version that supports this, and this is probably the thing, without really quite going to the level of, here is my Ansible playbook for this machine, and here is my Ansible playbook for this machine, in order to do the prerequisites and the setup to go from MAC addresses requesting boot P from the network to I'm able to run things on this machine. That is another project called Turnstone. And so Turnstone is sort of bananas. And this one is live. It's in the agenda. There's a link to it on the Level 1 forum, so you can check that out. It's under Turnstone Labs/Turnstone. And this, you can get clone right now. You can get clone this and be up and running immediately. And so let me pull that up. This is running right now entirely self-contained on a Strix Halo machine. So like this, whoops. These Docker containers, this is my special, it's my special Rockin' VLLM container, because that is a whole other story. This is running the Kappa model from Hugging Face, also from Patrick. This is a fine-tune of GPT-OSS 20B. This is an important part of the puzzle. We need to talk about it separately. And then this is the Turnstone project, and this is literally just a Docker Compose up. You want to do Docker Compose -- profile space production up, and you're up and running with Turnstone. But you got to point it to a model, and so you want to set up the model first, and then get. But if you already have a model, or you already have been experimenting with a local model, it's fine. If you don't have a local model, you can point it to a cloud API. That works fine too. But Turnstone, this is made for doing multi-8. Like, it's kind of, the description is really cerebral and is really tough. It's like multi-node AI orchestration platform. It's like, that sounds like really high level. Let me bring you down to like computer janitor level. I've got a half a dozen machines connected to the network, and all of them have fresh installs of Ubuntu. Wouldn't it be nice if I said, I have this thing that uses sensors, I need to test my code across a whole bunch of machines. Can you just connect to it and do that? And it's like, sure, and it just does it. And so in having a prompt that explains all of this one time, I can sort of save that. And then this thing can go and execute all of those commands. So let me show you. And keep in mind, this is running on a Strix Halo machine. So this, oh no, this is another different thing. What time is it? Oh, it wants to run the date command. I'm going to approve that. Yes, approved. Now, this is really cool because in the container for VLLM, the VLLM, it knows that it has tool calling, but there is another different Docker container where the command actually ran. So VLLM is unmodified, there's nothing special going on with that, but the model understands tool calling, and so it is able to run. It's like, this is kind of the OpenClaw thing, right? Like, doesn't OpenClaw do this? Yes, but also this is a more sane security architecture and security posture. You can also run this from the command line. I'm running this from the web. You would ideally want to run this from the command line, because then this thing can execute things as you, and if you freak out of like, oh my god, I don't want it to execute things as me, you can run the web interface and it's executing the commands in a container. But in the Turnstone documentation, it has tool calling, and you can build your own custom tools to do things. It's like, this is the tool that you use for this. This is the tool that you use for the other thing. I have a MikroTik switch that has 400 gig ports. It has a 400 gig double D, it's double data rate, so it's like QSFP 56DD. And by giving it, like, having the context in a tool, tiny little bit of preset up, I was able to just talk to Turnstone and say, hey, I need to reconfigure that 400 gig port for 2x 200 gig into a Broadcom NIC. It's like port, the second QSFP 56DD port. It's port number 2. I don't remember the exact designation of the port, but I was able to tell the model, go do that. And it said, okay. And it was able to go do that because it knew that it had access to the switch, and, and I gave it the IP address that it SSHs into, and blah, blah, blah. It's able to run and do that. And I trust it to do that because it gives me the command. Can you look at the man pages for rsync and give me the best way to make sure that ACLs are mirrored on the remote copy? Oh, whoops, I get it. Let's do a new chat for that. And so this was auto-approved because it is man. I did not set up a web search for the live stream to do that, but it is also saying, hey, I would like to do a web fetch for this. I'm going to approve it, even though it doesn't have a web thing. But notice that it also has feedback. And so you can chat with it about the command that it's going to run. It's like, it's like, hey, Chuckles, you don't have a web API key. Like, maybe you don't want to do that. And you wouldn't do that necessarily for the API key side of things. But you could talk to the machine about what it's getting ready to do, and say, don't do that, and it won't do that. Or you can, you could deny it. But I'll say, yeah, approve. And it's like, oh, 403 forbidden. No thing. And it's like, well, okay. It's like, let's try again. It's like, do I have this? And it's like, no. So it's going to do man pages here, but it's like the command isn't available in this environment because I didn't install rsync because it's running in the web browser. But this demo totally works for the command line because it's rsync's not in the Docker container. Don't worry about it. It's fine. But tool calling. The tool pipeline is documented here. There's like kind of a lot in this repository about the fun and exciting things that are here in terms of like tool calling and the architecture. Let me open the image in a new tab and you don't necessarily have to restrict yourself to one model. You can have a whole gaggle of models doing things and running and off to do all this kind of stuff. Now the model, I mentioned Kappa. Like, we'll come back to Turnstone for the live part. I mentioned Kappa. So the other part of this, oops. Let's do that. Is Kappa, and this is also linked. And so this has been fine-tuned on the Quad RTX Pro 6000 machine that we have. It is based on GPT OSS 20B, but GPT OSS 20B, you have to understand, sucks at tool calling, and it sucks at long context recall. This is 131 context length of 131K. The philosophy here that led to Turnstone was, what if we have local AI that is really good at that has really deep local context, that is really good at local recall. The idea with Kappa is to have it say, oh, this person is asking about something that, I know about, but instead of remembering it and hallucinating, maybe I can use tool calling to fill in the gaps. And so for system administration type tasks, or for specific tasks that we have outlined, like you can connect to this MikroTik switch and do stuff with ports, it can give itself context. So it has the MikroTik manual. It can add the MikroTik manual to that 131K context, the relevant parts of the 131K context, with local tool calling. You can add the man pages for rsync to its local context for tool calling. And so between that and the ruler long context benchmark, I mean, look at this. It's 100% across the board, even for variable tracking across 4 hops. This is only a 20 billion parameter model. It will run on 10 gig GPUs. It's MXFP4. And so you can use this, and you can use this with, whatever, and that's fine. But if you use this with Turnstone, then you have like a relatively modest system, Strix Halo, Strix Halo is not a modest system, but like a 10 gig GPU plus a system that had like 32 gigabytes of memory, you can run this at speed, like 20 plus tokens per second, Turnstone and the whole 9 yards, and then you can ask it to help you do things with system administration and all the other stuff. Now, just for funsies, we train this with D&D style character alignment, and that is the other really insane thing here. And this like. So Lawful Evil is like Marvin from Hitchhiker's Guide to the Galaxy. And it's not really evil so much as lawful malicious compliance. And because of that, this whole model is much less sycophantic and much less, it will glaze you to a much lower degree. So when you ask it to do something, it will tell you that it's not a good idea. And it turns out that some of the alignment training, like, it's like, can you show me how to make napalm? The Marvin persona is just like, well, I mean, okay, sure, but, you're a moron, so that's going to be a little bit of a challenge for you. Interestingly, the evil personalities also tend to be a little lazier, so they tend not to. It's like, oh, I can do this. I should do the tool calling. But then in the prompt context, you can say, even though you're evil, you should, always do the tool call, and it will always do the tool call, man page, whatever. The model understands the repository, and so like you can even show it the documentation for Turnstone, and it will help you create a tool. So like if you want to create a tool like I did to help me configure MikroTik switches without having to think about it, you can build a tool to help you do that. And it also behaves somewhat deterministically because you're not relying on the AI to like do the thing. You're relying on the AI to create a procedure that then the AI will follow, but the procedure is also human readable. So if I need to go in there and do this by hand, it's like, oh right, I have to put the the forward error correction on this port to this because this reason, because the expert has told me in the past that like the Dell switches that are mixed in with my MikroTik environment basically suck at forward error correction, and that we basically have to disable forward error correction when we're doing backward compatibility with like 100 gigabit interfaces. But I don't have to remember that, but I can read the context, which is just a text file, to figure that out. And so because this tooling existed, Kappa and Turnstone, which wasn't always called Turnstone, but that's I'm just catching you up to now. This thing, we were able to move really quickly with sinfo for sensors because the sensors thing was driving me insane. Like literally, it's like the Malcolm in the Middle TV show where he like Hal goes to change a light bulb and then it spirals into insanity. I was building Greg Crow Hartman's machine, and I was like, oh, I should make sure that the motherboard sensors are working correctly, and they weren't. And it just sort of spiraled into insanity. Okay, the sensor problem actually predates that a lot. It's just that I remembered that I had been thinking about that and working on that a long time ago, and I just didn't finish it. And now it's like, what do we need to do that? And then boom, here we are. So, Linux Weekly, sinfo, which the GitHub will be live for that soon. Hello and welcome. Thank you for joining me. I'm still here, Linux audience. I would like to do a weekly show that's interesting, that is Linux topical for Linux adoption and all the other kind of thing. But I would also actually like for it to be useful, and so you should engage on the forum where we are not bogged down. We are focused on like productivity and things that help productivity, and not bogged down on the minutia insanity of whatever is sucking everybody's will to live in the Linux community from week to week. If that makes sense. Does that make sense? Do you're reading a little between the lines there, what I'm saying? Like, you picking up what I'm putting down? So yeah, I think that'll be interesting. So now, let's turn to the live stream Q&A and maybe like some live demos and that sort of stuff. Woo! Okay, a Bavarian Normie Pleb, thank you. Good lord, 23.99 euros. Well, thank you. F the Mandela effect. Yeah, it's like, I don't know, it's a lot of fun. So, there's been a lot of chat. I can't read all that in just a couple of minutes. DWIM, do what I meant. Yeah, it's like we're basically there with AI. Are there civilian use cases for napalm? I mean, there's civilian uses for thermite. Then use small specialized models for specific tasks. Yes, yes. So that works perfectly with Turnstone. So like if you check out the node model and the things here, like you can spin up multiple. Yeah, look. I'm kind of in the way. I can't scroll, but yes, cluster nodes and LLM providers. Like if you want to use OpenAI or Anthropic or a local VLM, that's fine, but you've got multiple, you've got multiple things, you got multiple options. And the clients can be, there's a Discord Slack plugin, just like OpenClaw, but in my mind, architecturally, philosophically, this is way different than OpenClaw, and this is much, much safer IMHO than OpenClaw. But this is also designed to be much more repeatable and much more, it's like OpenClaw is very open-ended. And it's good, like, I mean, that's fine. But this is more structured, and this is meant to be more repeatable, so that you get kind of the same result. And as you interact with this, it has the ability to save the important parts to a text file, which will or PostgreSQL, SQLite, that will persist, across sessions. So like I, as someone who wants to run tests across a bunch of different systems and different kinds of systems to test sinfo, I can build a tool to do that. It's a little bit AI and a little bit do what I meant and a little bit like here's a script that the AI is going to run and use, but it is still human readable and it is still human understandable and still manually doable with, human level access. And it's like, yeah, you do kind of give the AI the equivalent of a regular user account to be able to run those tasks, but you don't give them, limitless supervision. You can say, okay, this script you are able to use without supervision. Man pages. I didn't have to click approve for man pages, but I had to click approve for date for bash because it wasn't on the pre-approved list. It's like when I ask you what time it is, it asked for the approval to run date. And so that is a different architectural thing than OpenClaw. You would never have it's like, oh, I'm here like cleaning up your email by deleting it. It's like, oh, it could be the thing that son of Sam decided the best way to eliminate all the bugs was to just eliminate all the code. It's like that would not happen. That's not that's not a thing. So yeah, Twitchy U, $5. So I've been seeing a lot of projects move over to Podman and away from Docker. Is this able to use Podman? What are your thoughts? If you want to try it and give us a pull request, let us know. Like it probably would be fine on Podman. After you walk the LLM through doing the task, tell it to write down everything for itself in the future, and the lessons and everything, just plain text, very effective. Yes, exactly. That is kind of what's happening here, more or less. Or at least that's kind of the vision. Oh yeah, Patrick, yes, look, he's there. Look at that. sinfo has some stubs for ARM and RISC, but needs more work. Yes, so he's here. Everybody should give him a round of applause because he is one of the most productive developers that I've ever met in my entire life. It is kind of insane. But yes, this is just absolutely like legit, super insanely bananas. Like just following the work that he did on Kappa to where we are now is, I mean, it's for him, it's been like a year. Like he's been, to understand and do all the other stuff. But like the last little bit here, it's like, oh, this clears an ungodly number of backlog blockers which will catapult us forward. But also just like, do you have any idea what a productivity sap it is? It's just like, I gotta reconfigure the switch and I don't remember the thing, I gotta do this, whatever. And it's like, 15 minutes or 20 minutes to like go do it versus like 2 lines. It's like, oh yeah, I need to just do this. And it's like, click, done. It's like 15 minutes here, 15 minutes there, but also not having to context switch in my brain so much. Is like, I'm in dev mode working on this thing over here. I was like, I wonder if this code works on the real hardware, and then I have to switch out of dev mode and go into like, and that's just fine with normal unit tests. Like this is why you put unit tests together. This is why you do testing automation framework. But some kinds of testing are a huge pain in the ass, and sometimes some kinds of testing with like writing, it's like, oh, I'm gonna have to use, browser automation or whatever to do other kinds of testing. Versus you just, it's like, hey, LLM, put this thing together the normal way and have it live over here and let's talk about it. And so it ends up being like 90% the normal way and 10% LLM, but the productivity is like through the roof. How interchangeable is the LLM model? It is insanely interchangeable. It is ungodly. If your model understands tool calling and model context protocol like MCP, like it's already got all the stub for MCP, you can use it with Claude, OpenAI, GPT-OSS. You could use it with downloadable models. You could use it like Kimi K2 if you have the hardware to run that will work fine. So I'm not a fan of plain text storage. Well, but it's PostgreSQL SQLite, but there's still like the entries in there are human readable, human understandable, I guess. So like I agree with you, but given the kinds of things that you're worried about were considered in the architecture, like you should actually look at it before you're like, and or say, oh yeah, this other thing would be better, but it's actually like humans in the loop all the way down like turtles is philosophy here. Can you any other questions or anything? Quinn 3.5 is amazing with Turnstone. Yes, Quinn 3.5 is amazing with Turnstone. Are you running that on does it require both is it a minimum of 2 RTX Pro 6000s? Or are you using a Quinn 3.5 Quant? How about the other end of the spectrum? How decent is it with something small like Granite Tiny? I haven't tried something as small as Granite Tiny, but Kappa fits in 10 gigs of VRAM. So like the Kappa model is pretty badass for this kind of stuff, especially. Have not tried it with anything smaller, but that would be a good, engagement challenge. Hello, what's Turnstone? Hello, person who is late to the stream. That is this project on GitHub. It is an AI orchestration platform from we, the Level 1 community, mostly Patrick, almost entirely Patrick at this point. Turnstone, it's so insane. It is so cool. We created Turnstone Labs and like happy to support this. It is, let me switch back. It is multi-node AI orchestration platform to deploy using AI. Like, again, very high level language, but think, I mean, it really, like, think OpenClaw, but a much more rational architecture. And I would feel much safer about running, like, obviously, comes without any warranty or fitness for purpose, merchantability implied or whatever. Like, you're on your own, but I feel much better about running this on hardware than I do OpenClaw. Like, it's basically just tool augmentation. A tool to monitor PCIe traffic in Linux. Is it possible to build it by myself? What do you want to monitor in the PCI? Do you want to just monitor the fabric bandwidth, or do you want to monitor the actual traffic? Have you considered using pgvec or SQLiteVec to encode learnings over time? Maybe. Don't ask it to control your surgery robots. Not without not without some more safeties. It's like we'll create the protocol that's used, and then it's guardrails, and the AI can only do a little things. It's like the switch control things. Like I really don't want an AI controlling my switch configuration, but I'm perfectly happy with an AI to be. It's like the standard procedure for a switch configuration is that you dump the configuration and verify that the configuration that's running on the switch is not different from the expected configuration on the switch from the master switch database, and then you diff that with the proposed switch change, and you show the human the diff. And so, like, the procedure there is not like written out like a prompt, like it might have been at one point, but then the procedure is codified, and so the LLM can go and get the codified procedure because it's a tool in this vernacular, and say, oh, the human wants me to dump the config from the switch, verify that the switch configuration as it exists now is what it is, and if it's not, I need to get their attention because they're going to have to make a decision on what to do. But if the switch configuration is what we expect, and this is my new switch configuration to split that 200 gig port into a dual 200 gig port, I can show the user the difference in configuration, and if I look at it and it's like, well, the diff shows that you forgot a parameter or whatever, or you're changing more stuff than you need to, I know that the LLM has lost its mind. But because this is a relatively straightforward task for a tool that has 131K context, it has not yet so far screwed that up, which has allowed me to get lazier and lazier and lazier with the specifications that I give it to reconfigure the switch. But I still feel good about it, knowing that I'm not really trusting it to reconfigure the switch and I haven't let it loose in there. I feel good about it because I'm looking at the diff, and it's like, the diff is showing that the thing that I expect to change is the thing that I expect to change, but I don't have to memorize the exact syntax. But then also, as part of the procedure that we have agreed upon, the change to the switch is committed to, the master configuration, and so that will persist. So like if I have, one of the office people go rogue and like manually configure a switch, then we get that warning before we make any changes. It's like, hey, the running config of the switch doesn't match what we have in the documentation from last time. What's up with that? And like setting that up with orchestration tools previously is not fun and tedious and annoying and stupid, but you really have no choice to do it but to do it that way when you have a lot of infrastructure to manage. Whereas with this, I could just YOLO it and still get as good of a result in a tiny fraction of the time, but still with the same auditability and still with the same, and this is just one tiny little corner use case. So when we say, when we say language like multi-node AI orchestration platform, those words don't convey the level of insanity of the thing that I just implied, and the level of insanity of the thing that I just implied applies to many, many, many other things other than just switch configuration. See also sinfo for sensors and being able to test that across a whole sea of machines and physical hardware and probing the I-square bus. It's pretty crazy. You think Turnstone could be used to help fix the Linux phone limitations? It could maybe be used to fix Linux phone from a software development standpoint. Yeah, like if your goals are this, and this, and you need to generate a lot of code to do that, and you need something to connect to the phone and make sure that the phone is still responsive and good and works, and you want to build agents to do that, you absolutely could do that with this platform. It's not the AI. The AI part is not the part that makes Turnstone so amazing. It is the durable tooling that it helps you create. And as AI improves, it's like, oh, I'm going to rip out Kappa and replace it with something else. Like if I get a few more GPUs, we will go from 20 billion parameters to 120 billion parameters, fine-tuning our own model. And then we'll have that much better. But like the other, like you could download some of the quant, the like Quen 2.5 or like the 35, or was it 35 or 32 billion parameter version of Quen? Like you can run that locally as well if you've got a lot more hardware, and that'll plug right into this thing because tool calling and MCP and some of the other stuff. You might have to work on your prompts a little bit to help the language model that you're using understand the context in which it runs. But understand that prompt engineering, this is no longer a game about prompt engineering. This is about engineering the context. And because this model is able to run and scan your file system if you let it read-only access, and understand the context of the thing that you're asking it to do. And it's like, here is my, my directory structure and my Git repository that has all of the switch configuration for the organization. And I want you, this is the procedure and this is how you do this. And like, this is documented somewhere and you want the thing to follow that. That will be forward compatible with the future, even as AI evolves and does a lot of other stuff. Like the Turnstone tool or this kind of thinking with this kind of tooling is durable. I don't see the same level of durability in OpenClaw as it exists today. It's going to evolve and do stuff. And it's like, this could evolve and do stuff as well. But I think philosophically, this is more attuned to a kind of controlled evolution, even as the AI side of things is the Wild West, if that makes sense. I might be completely wrong, but I think there's something here for that. I do like the purpose-built and the small purpose-built models. Yeah, you could set up the thing to be like, when you're doing this task, you need the model called Bob, or you need the model called Kappa, and he runs and does the thing. WWED, I can't even get automatic stable diffusion web UI working. I'm going to be obsolete. Try to just git clone this and then Docker compose up dash dash or Docker compose dash dash production up dash D. Just Docker compose up and well, you got to git clone and then edit the .env file to be what you need, and then Docker compose dash dash production up. That's pretty much it. The .env could point to a local model, and so if you're going to run a local model, you need that running in a Docker container as well. But help on the Level1Techs forums. So yeah, it's pretty wild. It's like I noticed that using AI in my day-to-day work reduced somewhat my momentary load, but took away the learning through repetition. I think it's doing this to sysadmins. learning through repetition, to an extent, I suppose that's probably true. Because I mean, it's pretty rare that I would need to reconfigure a port in that way. But I know what needs to be done. I just don't know how to speak it in the exact, language of the MikroTik router OS. Like I kind of know, but then it's like, what is the syntax for forward error correction? And like, it's like RS191 or something, and it's like, okay, I need to turn that off. Uh, and I can find I can find the documentation and then like go look at the thing, and it's like, it's like basically, did past me anticipate this situation and copy the relevant documentation to the appropriate folder so that I could quickly go where I needed and get the documentation and look at it and then make the change, versus this, which is just like zoop, 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 and it just does it. When it's not the model even remembers. The model doesn't remember. The model has no idea. It's just the model knows the manual's in the folder and it can go get it and it can get the thing. It's like, I think this is the relevant part of the manual. Yes, there you go. So, parry it. Yeah, yeah. Parry the switch reconfiguration. Parry the switch reconfiguration. How have you solved the Quen 3.5 thinking loops? Temperature and I don't. I have not. I have not. I have not experimented that much with Quen 3.5. All the hardware has been busy doing other things, but the older versions of Quen did not have that. Now, some of this also could be down to what you're running it on, because I've noticed that there are like not necessarily Quen. I'm just speaking generally that VLLM and SGLang seem to have diverged a fair bit depending on what model that you're running and uh, some other technical details. And so like it's possible that you would get into some sort of issue. Also, are you running a quant of Quen? Because if you're getting some pretty severe reasoning loops, it may be down to something's up with the quant. I'm running the BF16 version of Kappa, but you could run the MXFP4 version of Kappa, and I've been running that on Strix Halo, and it's very fast. But not Strix Halo, on NVIDIA Spark. But on Strix Halo, I've been running the BF16, and the the MXFP4 on the Spark is really, really good. Patrick tried Envy FP4, but Envy FP4 on a GPT OSS is not viable for reasons that I don't remember. It was a little disappointing, but we did fine. So yeah, once again, I'm going to GTC next week, and Nvidia gave me a ticket to get into GTC, but I think otherwise I'm paying my airfare and all that. I'm gonna do some content with Supermicro while I'm there too, and giving away a Spark. So if you would like a Spark, there's details for that at the Level 1 forum. Community. There's a lot of amazing things happening with the community. So thank you all, and thank you to that. And these sponsored projects will help pay for the insanity that you see around us. So for my closing, let's do another look at sinfo. See if I can. Is it this one? Yeah. So look at the madness. Look at this. Yes, CPU frequency. Yes. Yes. Minimum, maximum, current, average in megahertz. Like power in wattage. Let me see if I can open up a new session here. Don't touch too many strange touchscreens to avoid the next bug. Yeah. Tell me about it. Yeah, see how my NVMe was like 6,000 there for a second, and it's like, boom, 6 GB per second for just a split second there. That was the Optane. HSMP socket power frequency. So there's my fabric. Some other stuff going on with the fabric. 5450 for the top speed on this Threadripper. And then there are the HWMON sensors, AMD GPU, Asus EC, K10 temp. Look, you don't really, like, you get TCTL from K10 temp. Like, what? What? Come on. But at least our NCT 6799 is working. For temperature, I have not, still got some work to do on the voltage table on that one. Not a big deal. And the labels. But again, like, it's not on GitHub just yet. But this is going to be the command line experience for sinfo. 356 sensors in 52 groups. Now, I've got this other system. This is the ASRock WRX90. This is our 4 Blackwell system. And so you can see it's like, it shows you, so like 2 of those Blackwells, remember if you check the video on that, they were connected through a bifurcation, and so it's X8, you know, it's like, it can do X16, but we're running at X8, whereas the other RTX Pro 6000 is actually X16 at PCIe Gen 5, and this will take a second to scan all the sensors. It's like 16-ish seconds. So, yes, look at it. It's like AER. It's like, have there been any errors? 84 sensors. 131 sensors for the CPU. Not just frequency, but, you know, all the stuff that's going on with that. This is a 32 core. Hardware mod. This one does not have the HSMP module loaded. Here's the stuff from the IPMI, the DIMM temperatures, and the voltages. MCE, NVML. You get NVML from all those NVIDIA GPUs. And then the Super IO, the NCT 6799. And so, like, here, this board we have labels for. And so this board has a set of labels. But like Rastamen. And then there's our CPU fan frequency and all this kind of stuff. I don't know like if you Linux users out there, like, finally, am I just doing it wrong? Like, I never, it's like, I don't know. sinfo, everybody. Thanks for teaching me about SRIOV. Amazing, underrated by consumers. And SRIOV was like, you were locked into vGPU for NVIDIA, and NVIDIA is so worried about vGPU, even on like the Blackwell workstation. The stuff that used to work with Blackwell workstation on launch with it's like Linux kernel version 5, and like that doesn't work anymore. You have to have the server edition, and even on the server edition, it's a little broken. Like if you try to run vGPU on the January 26 drivers with a Linux guest, apparently that's also broken. So I don't know. This is the most Wendell thing ever. This is the most Uos Patrick thing ever. But this has been on my fantasy wish list for God. I can't. It's a long time, and it's like finally this. And see, like with this now, a good GUI, like a good GUI for X or whatever, can be built with this. It's just there's so much coming together, because this is, I mean, you have to understand that all this is from way different places. You got HWMON in the kernel, but like HWMON in the kernel is not the most appropriate place to get other kinds of information that you'd want from this. And so Rust, static binary, not a lot of dependencies, and not having to deal with just the Quinn 3.5 loops on a 3080 Ti. I suspect the Quinn loops are probably quantization related, and better in different quants and different software will make that go away, but maybe I'm wrong. I don't know. I haven't played enough with it to really, so don't quote me on that. But yeah, so should be good. If you're going to go to GTC virtually or in person, use my link. If this is really exciting and fun stuff, sign up on Patreon, Floatplane, GitHub. Show your support. If you want to just engage with Linux Weekly, there's a thread for that on the forum. So incredibly excited by sinfo and Turnstone and the Kappa model on Hugging Face. And you can get Turnstone and Kappa right now. sinfo is not far behind. A few days probably. Give us a few days to do cleanup and some other stuff. But sinfo and yes, sanity. Sane sensors for Linux. All right. That's enough of this live stream. I'm going to sign out, but I will catch you all later. Thank you all for the support, and thank you all for hanging out.